Welcome to Math Maxtra. This is Saritha. Today our topic is square. So what is a square? A square is nothing but it is a quadrilateral in which the pair of opposite sides are parallel and one of the interior angle is 90 degrees and the adjacent sides are equal. If a quadrilateral satisfies these three conditions, then we call that quadrilateral as a square. Okay. So what are the conditions? The pair of opposite sides are parallel. Okay. So these two are opposite sides, sir. These two are parallel and these two are opposite sides. These two are parallel. And one of the interior angle is 90 degrees. Isn't it? See, this is an interior angle 90 degrees and adjacent sides are equal. See, this side is equal to this side and this side is equal to this side. So this side is equal to this side. Okay. So this is a square ABCD. See, if you want to tell the definition of a square in terms of parallelogram, how can we define it? A square is nothing but a parallelogram in which the adjacent sides are equal. Adjacent sides are equal as well as one of the interior angle is 90 degrees. If a parallelogram satisfies these two conditions, what are those? One of the interior angle is 90 degrees and adjacent sides are equal. Then we can call that parallelogram as a square. Okay. If you want to see this is a parallelogram. So what we are doing? We are making one of the interior angle as a 90 degrees. Okay. So this is a 90 degrees. Okay. And adjacent sides are equal. Okay. This side and this side are equal. Yes. This ABCD is a square. ABEF is a parallelogram. So what we are doing? We are making one of the interior angle as a 90 degrees and we are making adjacent sides are equal. Then this parallelogram becomes a square. Okay. If you want to tell the definition in terms of rectangle, so it is a rectangle. Square is nothing but it is a rectangle in which adjacent sides are equal. See, this is a rectangle. So what we are doing? We are making adjacent sides are equal. See, if we make adjacent sides are equal, what happens? This is a, this side, this side, this side, this side are equal. So already we have interior angle as 90 degrees. Yes. So this ABCD will become a square. Okay. If you want to tell the definition of a square in terms of rhombus, so a square is a rhombus in which the one of the interior angle is 90 degrees. See. So this is a rhombus. So what we are doing? We are making one of the interior angle as a 90 degrees, which is nothing but here 90 degrees. Then automatically all the sides are equal in rhombus. So this also happens in the case of square. So if one of the interior angle is 90 degrees, then a rhombus is called as a square. So both a square is nothing but it is a rectangle and rhombus. A square which is both rectangle and rhombus. Okay. So these are the different definitions of a square. And now we will see what are the properties of a square. Okay. So what are the different properties of a square? As every square is a rhombus, it holds all the properties of rhombus. As every square is a rectangle, it holds all the properties of rectangle as well. So along with those, and it has some special properties. So what are those? If you take a square, this is a ABCD square. So what we know? In the square all the sides are equal. See, all the sides are equal as well as all the angles are equal. So all angles are equal and each measures 90 degrees. Okay, so a square has all sides are equal and all the angles are equal. Each angle measures 90 degrees. Okay, this is the first property. And the second property is the diagonals of a square. If you draw diagonals of a square, these are two diagonals of a square, which are AC diagonal, BD diagonal. These two diagonals are perpendicular bisectors as well as they are equal in length. See, what we have seen, perpendicular bisector means this diagonal divide this diagonal into two equal parts and this diagonal divide this diagonal into two equal parts. Means they are bisecting each other and perpendicular bisectors. Diagonals are perpendicular bisectors, means they are perpendicular to each other and those two diagonals bisect each other. So along with the bisection, perpendicular bisection, the length of the diagonals are equal, which is nothing but AC is equal to BD. So these are the length of the diagonals and they are equal in case of square. Okay, this is the second property. So third property is, if you take a square, this is a square ABCD. If you draw one diagonal, this AC is diagonal. So this diagonal divide the square into two congruent triangles. Not only congruent triangles, they are congruent right angled isosceles triangles. See, this is a right angle, isn't it? So this ABC is a right angle triangle. Along with the right angle triangle, we know the adjacent sides are equal in case of square, isn't it? So these two sides are equal. So this triangle will become right angled isosceles triangle, isn't it? So, and this triangle also, AADC triangle also right angled isosceles triangle, and these two triangles are congruent to each other. So then each diagonal of a square divide the square into two right angled isosceles congruent triangles. Okay, and the next property, fourth property is, if you draw two diagonals, what happens? These two diagonals divide the square into four congruent triangles. See, as this is a perpendicular bisectors and equal in length, the parts of the diagonals are equal, right? All the parts of the diagonals are equal and all the sides are equal. So what happens automatically? So four congruent triangles, the square, because of the two diagonals, the square is dividing into four congruent triangles. Yes. Length of the diagonal. The length of the diagonal is always root 2 times of the side of a square. If AB is a side of a square, so the diagonal is always measures root 2 times of the side of a square. Okay. These four congruent triangles, not only congruent triangles, they are right angled isosceles congruent triangles. See, these diagonals are perpendicular to each other, right? So, and these are also perpendicular. These are also perpendicular. So, this and these two sides are equal. So, right angled isosceles congruent triangles. So, these two diagonals divide the square into four right angled isosceles congruent triangles. Okay. Next property is, every square is a rhombus. Just now we have discussed the definition of a square in terms of rhombus, right? So every square is a rhombus, but converse need not be true. Means in every rhombus need not be square, because sometimes in a rhombus the angle may not be equal to 90 degrees. That time the rhombus will not be a square. Okay. So converse is not true. Every square is a rhombus, but every rhombus need not be a square. And every square is a rectangle. Yes, but every rectangle need not be a square. Sometimes the adjacent sides may not be equal in case of rectangle. So in case of rectangle, that is why. So sometimes rectangle may not be a square, but square is always a rectangle. Okay. So these are some different properties of a square. Next quadrilateral is kite. What is a kite? A quadrilateral in which 3D kite, these two adjacent sides are equal and these two adjacent sides are equal, but these two are not equal. These two adjacent sides are not equal, as well as these two adjacents are not equal. Only one pair of adjacent sides are equal. So AD and AB are equal. This is one pair of adjacent sides, and CD BC are equal. This is one pair of adjacent sides. This pair of adjacent sides are equal and this pair of adjacent sides are equal, and that is not possible in case of these two adjacent sides and these two adjacent sides. So that we call it as a kite. And in these the diagonals always perpendicular. So in case of kite the diagonals always perpendicular, but those not bisect each other. See this AC diagonal divide BD into two equal parts. These two are equal. But this BD diagonal don't divide this into two equal parts. These are different. These are different parts. Only this AC diagonal only divide the BD into two equal parts. Okay. So that is possible in case of kite. Okay. A kite is nothing but it is a quadrilateral in which two pairs of adjacent sides are equal. See how many pairs we have? We have four pairs of adjacent sides, right? So in those four sides, we have only two pairs of adjacent sides are equal. Then we call that quadrilateral as a kite. Okay. So these are all types of quadrilaterals. We have discussed all the quadrilaterals and their properties. Thank you.